Hi. Hi, welcome. Is the microphone working? Doesn't sound like it's working at all. Okay, I guess if you guys quiet down, hopefully you guys in the back can hear me. You guys are okay? All right. Well, welcome. This is ECE 2240. If you're not in this class, you're welcome to get up and go. So ECE 2240. I know we had a few from different classes earlier. So, all right, welcome. I'm Professor Angela Rasmussen. So I've been a faculty here for 20 years. So I have quite a bit of experience. I'm excited to teach this class. This is the second time I'm teaching this class. So there'll be a few little adjustments as we go along, just because I haven't taught it as many times as I have some of the other courses. I try to have a lot of resources available. So if there are things that you're like, this would be nice to have as far as a resource, please let me know and I will try and supply that to you if I can. So the first thing that I want to go over is that the Canvas website is published, so do utilize this. So right here is the book that we're going to use. It's a free PDF book. If you want to get a hard copy, it's $75, but you can use the free version for free. So I highly suggest that. Make sure you have the book. In the book, you're going to want to use that to read the chapter, to understand the material. You're going to want to do the problems and the exercises that are in there. In the very back of the book, so if you scroll down on all the PDF pages, there's going to be some answers to some of the problems. Again, that's a way to get extra practice problems where you can solve the problem and see, oh, I didn't do it right because the answer doesn't match there. So that's one place that you're going to get a lot of extra practice problems. The other is this test your knowledge. So on this test your knowledge, which I put on that main page because it's very helpful, are these self-assessments. So this first little bit is going to be a review. Some of you may need to review more than others. So you may want to go back in the book and review on your own based on where you are. And then say like from chapter 2, you're like, oh, do I really remember this or not? Let me see. Let me do an assessment. So come in here, try and solve this problem, put the answer in, say you think it's 10, and you can check your answer. Nope, that's incorrect. And then you can look at the solution to see how do they do it. You can then refresh the page and you will get sometimes new problems that come up. So every time you refresh the page, you can have new problems that are in there. So this is another place that's very nice to have practice problems. So this is going to be a place that you can practice. You can get a solution and then use that to learn and then try another one on your own until you're feeling like, oh, I can do this on my own without having to keep looking at the solutions. Just because there's a lot of material there for you to help you practice doesn't mean that you have to study on your own and spend the time and energy. So make sure you're allocating enough time for this class. I typically suggest for students that you are preparing 3 hours outside of class for every hour you're inside this class. So it is still a nice intense class, but as long as you are spending that time practicing problems, you will do really well in here and all of you can get an A. So I would encourage all of you to do that. All right, so the other thing I've put on the main page is the schedule. So on here, I'm going to have homework and assignments are going to be due every Thursday, except for test week. And then every Friday, there'll be a quiz. So we'll have lectures Monday, Wednesday, and then Thursday will be practice. And then Friday will be a quiz. Okay, so just plan that out. Those times on Thursday and Friday are based on when you're available. So you have up to midnight to be able to do those. The homework and assignments will be available. Even now they're available, so you can even go in and start working on those. So they're just due by the end of Thursday night at midnight. And then Friday, it will be open at 8 a.m. and then close at 12 p.m. So anytime in that Friday day, you're able to take the quiz. Okay. Any questions about that so far?
Is there time restriction on time that
So homework and assessments, no timing. You can start it. You can go do some practice problems. You can come back to it and then submit that one. You can redo that one for the homework, I think up to 4 times. And so you can get 100% on it. Basically, it's to get you practice so that helps you get ready for the quiz. The quiz is then going to help you get ready for the exam. So that's kind of how it's going to be paced. The quiz is 100 minutes timed. The exams will also be timed for our class time. So those will be the timed ones. And so you want to practice enough that you're like, okay, I can do this in, I give you 100 minutes, but please try and do them in 20, 15 to 20 minutes is kind of about what you want to be able to do a problem in. Okay. Other questions? Yes.
Do you have multiple attempts on the quizzes?
So only 1 attempt on the quiz. So make sure you're using the practices. So that self-assessment from the book, the homework, you can do again 4 times, but kind of practice on your own is what you're going to do. Practice with the homework and then do the quiz. Does that make sense? Okay. Any other questions? All right. And because these are online or remote, you have open notes, open book. The only thing not to use for the quizzes would be like ChatGPT, which doesn't work, by the way, very well. I did try it out. And it has lots of errors in it. So I don't suggest trying that because it doesn't work for our area. Maybe I shouldn't say, don't trust the answer because a lot of them were wrong. So use your book, use your TAs, use the tutors, use myself to be able to get through the homework. Chegg is another one. They give lots of errors in their answers. So do not use those for quizzes. You're welcome to use those if you want to have somebody kind of help you with the homework. But again, it's not going to really help you if that homework is supposed to help you prepare for the quiz. So quiz exams, not able to use those at all, but if you want to use those as trying to help you with the homework to learn, and that's one way you learn, that's okay. But again, ChatGPT gives you lots of errors, and so does Chegg. I had a student last year that used it, and I'm like, every single one was wrong. So don't trust the tutors there. Other online platforms, not acceptable. All right, so here I've also listed on here, like this week, you're going to have 2 assignments. So these are very short things. Just get them done on by Thursday. One is just tell me about yourself. So it should be pretty simple. The other one is just a discussion. And in that discussion, okay. So in the discussions, I'll go back to that one. You can find the discussions either in the assignment page, or I typically like to use this modules. So here are the course introductions. So here, start here. This gives you a little bit of brief introduction about me. It's like 1.5 minutes long, I think, or 2 minutes. So feel free to watch that. And then this gives you a little video on how this course is structured. And then there's course resources. So this is going to have, oh, I have the wrong one here. It will have resources for LT Spice, MATLAB, and circuit design, system cards, and a few other resources. I'm going to update this because it's missing the LT Spice. And then this is the assignment. Tell me about yourself. Just fill it out, submit it. It should take you maybe 10 minutes, 15 minutes, very short. If you do already understand your learning style. If not, it will take a little bit of reading to learn more about yourself. So the idea of that one is to learn about how do you learn the best for you. So you guys have had some classes behind you now, so you kind of have an idea, but if you haven't read that, I would suggest reading that learning style so that you can figure out for you what is the best way. All right, the next section here is called lectures for the semester. So here I'm going to have the lecture. So this is what we're going to start today. So any of you who have electronic means that want to download that, you are welcome to download those notes. If not, you want to print them out beforehand and come with a physical copy, feel free to print those out and come with those copies, and then you can write on the notes that I have. Once those have been done, I will upload the lecture notes, and then I will try and upload the video recordings. Most efficient is to come to class, participate, be engaged, and learn while you're in here. That's going to be the best way to learn. If you want to still try and learn on your own, it's good to go back and review the video lectures. You can go back and try the problems that we work through in here. And so use it as a way of a backup instead of your only means of learning. It's not as efficient to try to learn it on your own. And so asking your peers, asking me, we're going to have hopefully a pretty interactive engagement throughout the semester. And so I like to encourage that participation where you try your problem and then you go, oh, this is where I get stuck and I don't know where to go from here. And that way you can see what would be my next step when you're faced with that similar kind of problem again. Okay. I also have previous lectures if you do want to use these from past years or last year's when I taught this. So those will be down underneath the past video lectures. So you can go back and watch any of those also for review. I will be using mostly the same notes, but there'll be some here and there that won't be. So you're welcome to kind of go back and review. I do a lot of what's called active learning exercises in here. And so you'll see on those screens in the videos, even in here, there'll be like nobody up here and it'll be quiet for a while because I'll be walking around and engaging with you guys. So just note that on the video when they go blank, that's pretty much what's happening on those. All right, so the next sections in these modules is I have this first page is usually an overview and instructions. So this will outline all of the material that you're going to be going over for this first unit of material before we have our first exam. The next section in here is going to be the learning materials. So again, I have that test your knowledge at the top of these pages, and then a link to the book again. And then these are going to be the daily lecture content. So I'm not going to re-lecture these. I would like you to try to watch these before coming. So for next Wednesday, just briefly kind of look through these. You can go ahead and if you're like, I'm comfortable, I remember this really easily, test your knowledge, see if you got it. If not, go back and watch some of these videos to help understand them again. And utilize as much as this is needed to be able to learn the material, okay? So it's at your own kind of pace. And I hopefully have enough material on here for each kind of section. Oh, there you go. Okay, there it is. Okay, so capacitors, inductors is kind of where we're going to start. And then there's going to be the separation of variables. The links that I have here go into more details about how that works. I'm going to go through with just how do you do those steps. And then again, waveforms, RC circuits, RL circuits, and then the math for second order linear equations and RLC circuits. So math 2250 is the co-requisite, meaning that you can take it at the same time in here, which is where you're learning linear algebra. But I think in Calc 3, my understanding is that you guys learn some separation of variables. Is that correct? I'm seeing some head nods. If you guys heard separation, who here by raise of hand has heard of separation of variables? Okay, good. All right, majority of you, few of you have not, so don't be scared, it's okay. If you haven't, use these videos and then search also for other math videos on separation of variables so you understand more of the background of it. And then also that second order linear equation. This is going to be where, let's see if I can blow this up a little.
In this lecture, we summarize a method ratio of the driving function A.
I can't see it as well. Anyway, it's where you have the dt squared on the bottom. So this would be kind of your second order differential equation. So this goes through like, how do you solve this once you have this second order differential equation? So this is the math side of it. I'm going to go over step by step how to do it, but I'm not going to go into the background of deriving all of it. So if you want some of the derivations, rely back on these videos for that. Okay, so this is all the content in our first unit of material. So we're going to go over capacitors, inductors, and how do you solve the circuits that have them. You guys have already seen some of this in 1240. We're going to go into a little bit more detail, and then we're going to go into RC, RL, and RLC circuits. And so we're going to go also to like, how do we do those with the math equations of those? So that's our first unit of material. And underneath here, I give, again, some other written examples that you can kind of work with. And so hopefully there's enough material. You have lots and lots and lots of practice. So from this, what am I trying to get you guys to do? Thank you. Practice. Say, that's where you're going to learn, like, can I do this? Okay. So practice problems, practice problems. So as you're studying, practice problems. Okay. So read through the material and then practice, 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 practice. Okay. All right. This section is for some of you who may have taken a little break from circuits for a little bit. This goes back into some of the basics. So again, some content that you can use to review. Again, your book is great. Use those self-assessments to make sure you remember how to do Kirchhoff's laws. And then node voltage is usually my favorite method. So you're going to see me use node voltage a lot. So if that one you've forgotten, kind of go back and do a little review on those. All right. Questions about kind of where we're starting, structure of the page, the pages in Canvas?
How can I get to this page?
So it's just the 2240 on your courses. It should pop up as one of your courses. I just published it last night. So if you didn't see it before last night, probably because I hadn't published it yet. So it should be published today. If you're still having issues, let me know. Yeah, it says publish. Sometimes I forget to publish things, so let me know if you're like, I expect to see this.
I'm just wondering how to navigate there from that.
Oh, okay. So here it's on the modules.
Okay.
Yeah. So that layout was the modules. This also has like another modules list a little bit differently. So this has that course introduction, the lectures are located there, and then this will be our unit 1. And so that will kind of pull up that same module
Yeah, thank you very much.
of all of those. And then underneath there, so this will also have that link. So I've organized it in units. So each module is a unit. And so unit 1 will have that overview and instructions, and then the learning materials, and then the assignments and homework and quizzes that you'll have in these sections. You had a question, Andrew?
Do you happen to know offhand what the ECE tutoring policy is this semester? Because I know between fall and spring last year, they changed it.
Yes, I think they're still working on it.
Okay.
So we have some great TAs and a grader in here. Unfortunately, maybe switching. He was going to come and introduce himself, and I'm like, I may not have you. So they're going to be great, though. I know the one that I said, please hire, is going to be great too. So I'll try and have them come on Wednesday or next Monday, and they can be tutors for this class too. So they'll be your TAs in class, in your TA section. Feel free to ask them if you want to work on some of this material with them outside of this class, outside of the lab session. Ask them if you can set up an appointment with them, and feel free to try to meet with them weekly. Some of you may want to meet with them weekly to make sure you're going to be really successful in the class. Others, you may want to just have a session set up right before the exam. And I'm also going to try and get the grader to set up some of those study sessions. So there should be hopefully a few ways of getting all that support.
All right.
And then I'll let you know once we get all of the other TAs for the tutoring center hired. I think we're still working on it. I think we have 3 of them. I just can't remember who they were. So yeah. So there should be some support available. All right, any other questions about content so far? Or any questions?
For the exams.
So they're open book for the exams, but I do suggest having a sheet of quick notes. So as you study, I suggest make your note sheet as you go. So if you're like, okay, I need to memorize this formula, write it down on a sheet, or have an electronic, one that you can print out. And so write down formulas. There's going to be some sheets that I'll refer to, so you don't have to rederive the equation sets. So you're going to want to print those out too. Some Laplace transform tables, you're going to want some of those materials. So just make sure that as you're going, you're like, okay, this is going to be something very useful. Keep a little binder of like, these are the notes I want for the exam. That would be my suggestion. But it will be open notes, open book, but definitely I suggest being organized to make sure you can do it quickly. The exams that brings up, okay, well, I'll go back to the syllabus. Any other questions so far about anything else? Okay, so going back to the syllabus part, I have my instructor information here. I will have my open office hours will be Monday and Wednesday right before this class. So from 10:45 to 11:45 a.m. But I also do by individual appointment. So you can click on my appointment availability. I have those open for classes, but I also have them open for just advising, mentoring, if you want to also come for an appointment for any of those reasons. But feel free to make an appointment if you do want. You can't meet during my office hours for some of the other times.
Are those online or are those in person?
There's an option for both. So usually Monday, Wednesday, I'll be here physically in person. So those appointment times will be in person. And then Tuesday and Thursday, Friday will probably most likely be remote. But once in a while I'm here, and so I'll have you can select which one you want. And when I'm here on Monday, Wednesday, there'll be Zoom options too, if you're not available in person. So I'll do both. So whichever method you prefer, I can meet with you.
Thank you.
All right, yes. Any other questions? Okay, also feel free to email me. I do respond to emails. Sometimes I may be delayed. So if it's like 3 or 4 days and you haven't heard anything, just ping me again. And I have 1,300 emails right now in my inbox. So I get a lot of emails, and it's not that I'm ignoring you. It's just that probably got put maybe in my junk mail, and just, I didn't see it if I don't respond. So typically just resend, like, I sent this, can you, do you have any update on that? Feel free to do that after 3 days. So if I haven't responded in 3-day time, most of the time I respond in a day. But again, I get lots of emails. So it's not that I'm ignoring you. I just get a lot of emails, but I do usually process all of them. So feel free to reach me that way if you prefer. You can also call. I usually don't answer as much with calls, but you're welcome to call and leave a message too. All right, so this is more just the information. Please go through this. I'm not going to spend a lot of time, just just kind of go through on your own pace. This is about the book. You don't have to have a computer, but if you, as I said, I have digital notes. So if you like to write on a tablet or iPad, some students have liked that. So you can download my notes and just write on that. If you don't have that, want to do physical copies, feel free to print them out and write on those. Again, my office hours, and then this is the schedule again. This is about time management and expectations, and then what you probably all want to know, like, how do I grade? So this is the grading outline. So you'll have 25% of the grade will be those homework assignments. So my assessments, I changed to homework, so they're the same thing, and quizzes. So that grouping will be 25%. 5% will be the assignments. 3 of those scores can be dropped, and that's because I don't allow late homework or late assignments to be turned in. Instead, I understand life situations come up, just use that to drop it. Homework practice problems, those are going to be 8%. I'll drop the 2 lowest scores, and then you have extra credit problem. There's going to be a section for practice problems. And so that will be like Unit 1 practice problems. Again, those will be ones you can go over and do again and again and again, and there'll be different problems. I've created a whole bunch of databases of problems like that website that you saw. I have some of those also of my own problems that I've created. So you'll get those practice problems also there. You can go and do them as many times as you want. Your highest score will be kept, and that can be also used as extra credit and replace a homework. So you can use that also. Quizzes are going to be 12%, and you get to drop the lowest 2. Okay. Any questions on grading for those? Okay. Exams, 3 exams. There'll be 3 units of material. My final is optional. And what it is a retake of any exams that you want a higher score. So I know some of you learn really well throughout the semester. If you do really well, you don't have to take any final. If you are one that learns like, okay, I didn't do well, but I know I can do really well later, that way you can do really well and still get an A, because you can do it later and take it at the final and prove that you have learned the material content. So my final exams are those optional retakes that you can take at the end. All right, any questions about that? Yes.
Is there a limit?
Yep, nope, you can take all 3 if you want. If the only thing is the timing, because there's only 2 hours. So I tried to fit it in where you could possibly do all 3 in the 2 hours, but they're like really quick. Like you have to be really quick to be able to do them. I typically don't have students opt to do all 3 because it's pretty intense. Yes, but you can do up to all 3 if you want to attempt that. And then whichever score is highest, I do keep that score. All right. And I think I heard that was my question too. Was that any other questions? Okay. All right. Okay, so again, no late assignments. I already went through the grading. Submitting assignments are going to be on Canvas, so do submit them on Canvas. There'll be Canvas quizzes, and then the exam will be on Canvas also. So I've reserved the Engman Lab, and that's in here, L210. So it'll be on the 2nd floor in the Engman Lab. So you'll have that room is where we're going to take our exams. So just come prepared to be in that room instead. And so you'll take it on Canvas. You'll be required to have only any tabs you have open, you'll need to have them next to each other. So there won't be, I won't allow anybody to have tabs underneath tabs, if that makes sense. So you'll have to put in the window where I can see all of your tabs that are open. You're welcome to use online calculators. I'm fine with that. You just can't use MATLAB, but you can use a different online calculator. So Wolfgram, I think a lot of people use, anyway, whatever Desmos, you're welcome to use those, get familiar with them, understand them, because some of my questions sometimes asks for the understanding part of it instead of the answer. So just note that we'll be meeting in that room. You also can meet on Zoom. Again, on Zoom, I'll I'll have you go and show me your screen. And then if you take it and opt to do it on Zoom, you will possibly have to meet with me or a TA and have a verification of your work that you submitted if you did work online. So just note that if you take a remote exam, that will be like, there'll be another additional verification step on that. So I encourage everybody to do it in person in the Ingman lab when we meet for those.
Where these exams are open book and open note, and if
Yep.
we have, if we take notes on a tablet, how would that work in terms of taking an exam? Are we allowed to bring in our
Yep.
tablet? Okay.
Yep. Yeah, you can have your tablet, you can have calculators, I mean, physical calculators too. Just if you're using that, I'll ask the same thing just to see that you only have that one thing open. Okay. All right, any other questions? You guys ready for a review?
Yeah.
Okay. I like to jump in. So I'll tell you my style. I like to overwhelm you. And then we'll do lots and lots of practice in here also. So just know like these first few lectures may be a little overwhelming, but don't feel like you're not going to learn it because it will come. Okay. So swap sharing. Oh, and I forgot to mention, so there's a Zoom link on our page. It's just the Zoom link on the Canvas page. If you are sick, I do encourage you to attend remotely. Try not to spread. I also request I have a disabled son who has no immune system. So I'm always trying to be very careful myself. So if you have any symptoms at all, I would encourage you to wear a mask when we do active learning activities when I'm walking around, please. Or just kind of hold up your hand and I'll put on my mask. So just be conscientious of that and be respectful if you don't mind for that reason. I would appreciate it. And that's why I also allow the Zoom and encourage do attend remotely if you are not feeling well. And if you're really out of it, go and watch the online lectures again, and then email me with questions or ask at a different time. But do please be respectful and try not to come if you're having really a lot of symptoms. If you're just not feeling the 100%, feel free to wear a mask and come. And also feel free to let me know so I can wear a mask. All right, thank you. Any other questions? All right, we are going to move to the notes. So these are the lecture notes that I referred you to. So again, if you're on electronically, you can just download these from that link. So capacitors, anybody want to take a stab at describing what does a capacitor do?
They emit a field, right? Or something?
They create a potential difference between two plates to store voltage.
Okay, great. So yes, there's a field because there's potential difference. So you get an electric field and you get mostly that you have charges on two different plates. And so they store charge. So I like to think of them as a battery. So with a battery, I think of a battery as literally like a 5-volt battery or a 9-volt battery. So something that has voltage to it, has potential on each side of it. So it stores charge. Which then correlates to voltage. All right, we're not going to go into all of the physics of it, but do refer to, you guys can kind of again go through these notes. This is going into more details. And then again, you can go back and look at those review videos on capacitors. What I want you to get to is more application of this. Okay, where did that? Okay, so thinking about what does a capacitor do to the current? So if you have like an RC, and this becomes like initially it's charged up, what's going to happen to the capacitor there? It's gonna what? Well, first off, when I have it connected, so there's 10 volts connected here. What happens in this situation? Thank you. So stores charge. And so charge keeps getting stored until it's pretty much to its capacity. And it's going to look like 10 volts. So they'll get to be 10 volts kind of charged there. And then when I open it, that charge is going to start to dissipate. And so you get this exponential decay. And it reaches a point where we call it that it's pretty much 60% has decayed. That's our time constant. So depending on what the initial condition was to what the end condition is. So our initial condition was it had 10 volts, and then it's going to discharge to 0. You can go the other way where it goes from 0 to 10 volts. And we still say that that 60% of 10 volts, which would be 6 volts, at 6 volts, we've reached our time constant. And maybe I should be more specific. It's 67%, but I usually say around. I'm going to say I like approximate things. So 60% of final value. It's in this one. So that's going to be this tau, which we'll go over where this form kind of comes from in a minute. But this is kind of, I want you to first understand what is the time constant. It's how long it takes to charge or discharge it. So that's one thing to know about the capacitor. The other thing is to memorize this equation of C dV dt, that I is equal to C dV dt. So this is going to be one equation that you're going to have to memorize. So that's one equation that you have to memorize about a capacitor. All right, so review again. Capacitor stores charge. That charge is usually related to voltage. And then memorize that equation that IC is equal to C dV dt. And that V is the voltage across the capacitor. Current is through the capacitor. So that's why it's IC and VC. And then tau is the time constant. And that relates to how long it takes to charge and discharge. And we say that that time is reached at whatever value tau is once it's 60%. So say tau is 0.02 seconds. And we were going from 0 to 10 volts. At 6 volts, that time that it took, once it was switched, took 0.02 seconds. So that's what that time constant means. Okay. Okay, now inductors. Anybody want to take a stab at what does an inductor mean? What does it store? It stores energy in a magnetic field that is related to current. So yes, energy, and that's relatable to current. So capacitors store charge, which ends up being voltage. Inductors store energy, which relates to current. So again, memorizing an equation here, that's going to be, it's hard to read that one. So this is going to be the voltage across the inductor L is equal to L DIL dt. And that's going to be the equation that you're going to memorize. So just like with the capacitor, it also has a charge and discharge. So you're going to have a time constant. So that tau. All right. So now looking at this equation, what happens if you have no change in current? Say it sat there for a really long time. What happens to a di dt? It's going to go to 0, right? So if I is 0, then VL is 0. What does that mean physically in a circuit? If you have voltage between 2 points is 0, what element does that look like? A wire, a resistor, an open? It's going to look like a wire. So this is how to remember, how do we model what happens to this after it's sat for a long time? So an inductor after it's sat for a long time will be modeled by a wire. So it'll be a short. Going back to the inductor, I mean not the inductor, we just talked about that, the capacitor equation. Same thing here. If I've sat for a long time, I have no change anymore in the voltage change. So once that change goes to 0, what happens here? IC goes to 0, and that one looks like an open. So if you forget, like, I know I'm supposed to model this by something else, this is how you remember what it is you memorize that equation, and then you look at it again and say, well, what happens when it's sat for a long time? I have no more change. So that derivative has to go to 0 because there's no more change. All right, so now we're going to look at actual circuits. So we're going to first look at just an RL circuit. So it has a voltage. I'm going to call it VTH and RTH. So this is representative with the TH of a Thevenin. So this could be some other really complicated circuit that I've lumped up into the two elements of a voltage source and a resistance. And now I have a load of an inductor on there. And so we're going to go through the math of what happens here. So I have no switches in this circuit, so it's been sitting for a really long time. L is going to become a wire. But if I didn't know that, how would I go about solving this circuit? So I know that VL of T, L, is going to be, anybody have it memorized already? What's the equation?
LDI.
Thank you. L di dt. And this IL is going to be the current going through it. So IL. So if I do a voltage loop here, I'm going to start here and I go around. I like to label every element to have the polarity of the current through there. And then I'm going to always circle either the second one that I go to or always circle the first one. So this is how I know how to make sure that my signs are correct. So my voltage loop will be plus VTH minus RTH times IL. And that's actually of time. And then minus the voltage L. So there's going to be a VL across that. So here's my voltage loop, Kirchhoff's equation of going around. So plus VTH, the voltage drop across a resistor is I times R, and then the voltage VL. And I know VL from my equation. So I can rewrite that. And if I just put the differential portion of this on the other side, I get IL dt. And then that's equal to VTH minus RTH IL. And then I can divide by L. And now I can integrate both sides to get rid of the differential. So if I integrate this, I first need to, so this is part of that separation of variables. So I need to combine on one side the variable. So here's my variables are IL and or DIL and then DT. So I combine the ILs on one side, and then I'm going to have DT on the other side. So here I have DIL. Of T over IL of T times RTH and then minus VTH. And then on this side, I just have IL, and it's a minus IL. And then the DT comes on this side. Green. Okay. All right. Okay, so those are my variables. And then from here, I'm going to integrate to get rid of the D. Yes.
Shouldn't it be RTHIL minus? Oh, never mind.
Yeah, they're just, you can write them either way.
Yeah.
So you could write RTHIL or you can write IL RTH. So it's just a multiplication and RTH is the constant.
Okay.
All right, any other questions so far? Okay, so now from here, I'm going to do this from a time t0 to a time t, where t0 will be kind of like if I had a switch, that would be my initial time. So t0 is just initial time. And I'm going to put a recall. So when you have a du over au plus b, that is equal to 1 over a natural log of au plus b plus c. So that is why I left this VTH on that side, because I remembered this property and I've done this derivation before. So I put that in a form where I could match it to a table to do an integration. And so this ends up being natural log. Maybe I'll match these up. So my A here is going to be RTH. So this is A, U is going to be IL. And then B is a minus VTH. Okay, so AU, so RTH, IL of T, and then A minus VTH. And then that's going to be evaluated between T0 and T. And then on this side, I have minus 1 over L dt, and that's just going to be minus. We do this minus 1 over L evaluated from T minus T0. And so then this becomes the natural log of RTH times IL of T minus VTH minus the natural log of RTH IL T0 minus VTH. So another property, if you guys remember from logarithmic or natural logs, so if you have a natural log number minus another natural log number, you can do a division between them. So another recall. So this can become natural log of the RTHIL minus VTH over RTHIL T0 minus VTH and then this can become, so if I bring this, well, let me write it out, yeah. I'll shortcut it, but T minus T0 over L. And then to get rid of that natural log, remember you have to take E raised to it. So I'm going to put in E. And if I raise one side, I have to raise the other side to E. And so now that E removes the natural log portion, so we're left with the RTH IL of T minus VTH over RTHIL of T naught minus VTH is equal to E raised to I missed an RTH somewhere. Go back up here. VTH minus RTH. There should be an RTH in here. This. VTH minus RTHIL minus VL LDIDT over. Okay. Natural log. I wrote this wrong from here. There we go. Okay, so 1 over A, I forgot the A. 1 over RTH, natural log, AU plus B, that was where it was. Okay. Okay, so I was missing the RTH here. And so bringing this one becomes RTH on this side. Okay, so E raised to that, and then this can become RTH IL of T minus VTH. And then if I multiply this over to the other side, and then I can solve this for IL of T. By dividing, so I take over the VTH and then divide by RTH. So this becomes VTH over RTH. And then the minus becomes a plus. And then plus RTH is divided. So then this is IL of T naught minus VTH over RTH. E to the minus RTH over L, T minus T naught. So these become a final value of a circuit. And this is the same, so final value. This is an initial value for I naught or IL. This is going to be our tau. And so this becomes, well, 1 over tau, I should say. So tau is going to be L over RTH for an L, an inductor circuit. And hopefully you guys kind of, this looks more familiar. So this is what you used before and just found these values and plugged them into this formula. So now this is like going one step beyond to be like, now I know more math, I can actually go and derive this. And this is where this derivation has come from. So this is kind of the general form. You have some variable X, it can be the voltage, it can be the current. And it's going to have the final value plus the initial value minus the final value multiplied by E raised to the minus T0 over tau. And this is where that general form equation came from in the past when you used it. So we can still use it, and we're going to go through and solve some problems with these. You can do the same derivation with the capacitor. Hopefully this will go a little faster. So we can go through and do the same thing with the resistor and capacitor now. So what is the equation for the capacitor? The equation that I said to memorize for the capacitor? Yep. All right, so now when you take the loop, you have plus, minus, minus, so you have plus VTH. And so you plug this into the IC, and so you have C. C times RTH times DVC over DT. And then we isolate the DVC DT. And oops, I still wanted those. There we go. Okay, so same thing we end up getting with the derivation is we have that final value plus initial minus final times e to the minus t minus t naught over tau, where tau in this case ends up being RTH times C. So exercise is to go through this derivation on your own and make sure you can come up with this equation. Okay, so these are the steps here, but do use it as an exercise to go through and be able to solve. All right, I've kind of put one more page in here. So in summary, I went through and said, you know, memorize. So understanding is for capacitor. It stores charge, which relates to voltage. Memorize the equation. And then the inductor, it stores energy, which relates to current. And then memorize. Who wants to say it? What's the equation for the inductor? Go for it. Good job. Yep. So memorize that one. All right, we went through the solution for an RC and RL circuit. And we came up with the generic form of, we'll do capacitor first. Well, it's actually an RC capacitor. It solves for VC of T, and it has the form of final plus initial minus final. E to the minus T over tau. And for RL, it was IL of T that it solved. And again, it was final. I'm gonna copy this. Okay. And so they're both the same form. Tau is different. Here is RC, and here tau is L over RTH. So now when we look at a circuit, if it just has a simple one capacitor and one inductor, we can go back and use this form and solve for the circuit. So that's what we're going to do next. So this is kind of just more written out process. So we have the generic forms or the general forms listed there. So here's the general form for the capacitor and the general form for the inductor. And then you have tau for each one of those. And then at an initial time, so this would be your initial time, you assume that that circuit's been stable for a really long time. And then that's going to cause those derivatives to go to zero, which is either going to cause a wire to be there and open. And then you're going to find the value across the capacitor or across the current through the inductor. And then we use that a capacitor can't change instantaneously, nor can the inductor current change instantaneously. So they have to be the same right after the switch and right before. And then from there, we're going to find this will be your final value. And then find the equivalent RTH. Where it's seen by the capacitor or the inductor. Okay, so now we get to jump into actually applying
So
it.
is that taken forward as the algorithm for how to solve?
It's just a written procedural steps. Yeah. So I encourage you to rewrite once we work through some problems, rewrite it in your own words. Like, what are these steps that I need to take to solve a circuit that has an RC in it or an RL? So this is going to be an RC circuit. It just has a capacitor and then some resistances. So this will be our RC circuit. So after being open for a long time, the switch is closed at t equals 0. So it's sitting for a long time with it open first. So I usually like to redraw the circuit with each situation. So we're gonna do an initial circuit. And I love the iPad because I can just copy and paste this. Okay, so that switch is open, so it's disconnected from the other side. And when something has been sitting for a long time, and it's what is going to happen, and I'm going to replace this capacitor with something. What do I replace the capacitor with? An open, and why again? Why is it open here? Correct, because I had that equation memorized, and I know that I'll get used to my new iPad. I know that current, wait, CdV dt is equal to IC. And so with no change, IC becomes 0, which looks like an open. So that becomes an open, which means no current flows there, right? So when I have an open, it's just a dangling wire sitting out there. No current can flow through that. So what is the current flow? What's this current? Okay. Micro. I don't know if everybody said that. I heard milli. So micro, remember, is this symbol. So this is 10 to the minus 6. And then what's the current going through the 30K? Okay. 120 micro, because there's no current going through that open wire. So this voltage, if I was to color, okay, it's not going to color. It's this one. If I was to color this node, and I color, do the bottom one pink. This node, what is the voltage VC of T going to be there? Yep. So you can just use Ohm's law. So with coloring those, I noticed that that green is on top of the 30K, and then underneath it is the purple. So it's going to be the same as the voltage across that 30K resistance. And that resistance is going to be Ohm's law, I times R. So I can write that as VC will be 120 micro times 30K. K is what? 10 to the third. Thank you. So this ends up being 3.6 volts. This is considered my initial value for that general form equation. So now I want to find a final value. So in the final, what is this? So this is usually how you'll see some of these. I usually just recopy the circuit, leave out the inductor or capacitor in there, and then leave out the switch. And then I go back and determine what is the position for each one. So in this case, what is the switch doing at the final position? It will be closed, so it will be a short here. And what happens with the capacitor after it's sat again for a long time in a closed position? It will still be an open again. So we just leave this open still. And now we're going to find the same thing, back here. So again, the bottom is going to be this color. And we can do, I think I did green on the top. So again, it's going to be the same as the voltage across that 30K. Because the nodes are the same on the top and bottom, even though there's like little wires dangling out there, that voltage is still going to be the same. And so if I find this, I'll call it I2, VC in the final position is going to be equal to I2 times 30K. And so, as I said, I like node voltage. I2 is going to be the same going through this resistance, right? You guys see that? And then I can do a node voltage here. So say I call this just Vx. Using node voltage, I'm going to want to describe this current here. And what will that current be?
Yeah, it's the difference.
Correct. So remember, it's the voltage at the node, so Vx, minus any other voltage in that node over the resistance combined in that branch. So Vx minus, this is kind of floating here. So I'm going to ground it so that that is my zero. So it'd be Vx minus 0 over 10K. And the current, how do I write this one in this branch? Correct, minus 120 micro. Don't forget the units. Common mistake. Don't forget those units. That's 10 to the minus 6, which is very different than 120. And then how do I write I2? Okay, that would be a correct way of writing it. The issue is if I bring in VC, it's another unknown. So I would need another equation. So to simplify it, I'm going to ignore VC and try and keep it in Vx terms, and then go back and write it with VC once I know, or VC once I know Vx. Yeah.
Yes, minus 0.
Correct. Yep. So that will be, yes, you were right in that that was a correct equation to write, but then it adds in another unknown. So that would be why I would want to write it as Vx minus 0 over 50K. And now I can solve this for Vx. So I can either do this by hand, combine all of the terms for Vx, or I can use a calculator. And this ends up giving me Vx is, oh, I didn't write the number. Vx 0.6. No, I didn't write the number. Okay, so from here, now I can write VC, where VC is going to be I2, which can be Vx over 50K. Vx I2 times 30. Okay. So I2, which is Vx over 50K, times 30K, which is the resistance there. And that will be my final value, which ends up being 0.6 volts. The last thing I want to do is tau. And so I leave it in the final position is where I find tau. So this is one that is often forgotten. Tau you want to find, remember, it's 60% of the final value. So you put the circuit in that final state and then find out what is the resistances that I see. So this will be closed. When I find an RTH between the two nodes, I label them A and B. What do I do with the independent sources? You guys remember? You turn them off. So with a current source, if you turn it off, what happens to it? It becomes an open. Yep, open because I equals 0. And so with that, then my pathway comes in and I hit a node. So it's going to branch off. So I'm going to have 20K, which if this is open is combined with 10K in series. And then it combines back up with the 30K. So RTH here will be 30K plus, or sorry, in parallel. With 20K plus 10K. Which 30K in parallel with 30K will be just half of it. So 15K. So my full equation for VC of T will be my final value, which is 0.6 volts. My initial value, which was 3.6 minus my final value. E raised to the minus T, and then I forgot tau is going to be 15K times the value of 10 nano, which ends up being 150 microseconds. So minus T over 150 micro. And this is in volts. So that is my equation. And so you guys have all just been very overwhelmed by, here is how you derive the equation and here's how you actually solve it now in a circuit. So exercises, go and rederive the one for the capacitor, make sure you can get to that final equation. Go back through and rederive on your own the inductor, and then try and resolve this circuit again on your own. And then there's extra practice problems like this on those test your knowledge. And so I encourage you to try and go do an RC or an RL circuit. And next time we'll solve this other one and the other 2 problems that are on here. Three problems. Hi.
I'm Jackson. I sent you an email, I think last week about getting married.
Oh, you're the one getting married.
Yeah, and I'm gonna be gone between the 12th and the 18th of September. I just was curious, like, if I needed to square anything away ahead of time, or like what I was gonna miss, or like if it's gonna conflict with exams or anything like that.
Yeah, so the exam will be the 20th.
Okay.
So if you look on this schedule, let's go back to the schedule here. So you're gonna miss. Where'd the schedule go, evaluation, here it is. Okay. Stop this. And